Today's question is, what is the PSEPT structure of Ni5CO12 2-? So first, let us look at the structure. To get the structure, we need the skeletal electron pairs. So we have to calculate the skeletal electron pairs. And to calculate skeletal electron pairs, we have to calculate the total electron count. 5 nickel, 50 electrons, 12 carbonyls, each carbonyl is a 2 electron donor, so 24 electrons. There are 2 negative charges which we have to add. The total electron count is found to be 76 electrons. So to calculate the skeletal electron pairs, the formula is TEC minus 12N, where N is the number of metal atoms by 2. Total electron count is 76 minus 12 into, there are 5 metals, 76 minus 60 by 2. So the number of skeletal electron pairs are altogether 8. Once we get the number of skeletal electron pairs, from that we can derive the structure. For example, if I take S minus 1, PSEPT parent, is pentagonal bipyramidal. Later on we have to compare the number of skeletal electron pairs to the number of metals. The number of metals are only 5, but the number of skeletal electron pairs are 3xs. Therefore we call it as N plus 3 series, where N is the number of metal atoms. So S is equal to N plus 3. According to PSEPT, N plus 3 is closo, nido and arachno. But parent is pentagonal bipyramidal, therefore we give arachno. Pentagonal bipyramidal. Arachno pentagonal bipyramidal, and the original structure was found to be trigonal bipyramidal. So what is this structure? I'll just draw. You can get it in the exam, where they can ask you how many number of bridging carbonyls, how many number of terminal carbonyls are present in this nickel carbonyl. Well, this is the skeletal structure, trigonal bipyramidal. And coming to the carbonyls, there are 3 bridging carbonyls in the equatorial plane, 3 terminal carbonyls for the 3 equatorial nickels, altogether 6, 7, 8, 9, 10, 11 and 12. So each small circle is indicating a carbonyl. So this is the structure of nickel 5 CO12 2-. But if you carefully look at this structure, if I just take an equatorial nickel, is it obeying 18 electron rule or not? Let us check. Suppose if this nickel is having 10 electrons. So in this nickel, if I take this nickel to be 10 electrons, metal-metal bond 1 electron, so this is 11, 12, 13. This is 14, 15, 16. Then this should be 17 and this should be 18. So for this nickel it is 18, for this also it will be 18, for this also it will be 18. But look at for this nickel. Nickel is 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. So for these apical nickels, I am getting 19 electrons. Already it is Ni5CO12 2-. It means we have to take care of those 2 negative charges. But without taking care of those 2 negative charges, 2 nickels are already getting 2 excess of electrons. And where should I account for those 2 negative charges? So PSEPT fails to explain the structure of Ni5CO12 2-. It comes under low nuclear carbonyl clusters in some literature, whereas in some other literature it is given as high nuclear carbonyl cluster. But we have some magic numbers. According to those magic numbers, suppose if I get a total electron count of 72, the geometry is generally taken as TBP. For 74 it is taken as square pyramid. For 76 it is taken as triangulated net. And for 78 it is taken as bow tie, where all these are generated from TBP, breaking one bond, square pyramid break one bond, and triangulated net break one more bond, we will be getting bow tie. Here we got total electron count of 76, so if at all it is triangulated net, let us draw the structure of the triangulated net. If this is the structure of the given cluster, let us account for the electrons. Nickel is 10, 11, 12. So let me put 13, 14, 15, 16 and 17, 18. This accounts for 6 electrons. Nickel is 10, 11, 12, 13, 14, 15, 16, 17, 18. All the 3 nickels are in 18 valence electron count. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11 and 12. Now this nickel has 18, this nickel has 18, this nickel also has 18 electrons. For this nickel it is 10, 12, 13, 14, 15, 16, 17. Even for this nickel it is 10, 11, 12, 13, 14, 15, 16 and 17. So both of these nickel we are getting 17 electron count. There are 2 negative charges, so we can account for those 2 negative charges. Each negative charge we can add on to this nickel, so that every nickel will obey 18 electron rule. So provided that every nickel obeys 18 electron rule, this must be the structure, but originally the structure was found to be TBP. So that is the reason we say PSEPT fails. But for the examination point of view, the question can be how many terminal carbonyls and how many bridging carbonyls are there for nickel 5 CO12 2-, or they can ask you the skeletal electron pairs. The answer is skeletal electron pairs are 8 in number, series is n+3, structure PSEPT structure is arachno pentagonal bipyramidal. The original structure is found to be trigonal bipyramidal. There are 3 bridging carbonyls and 9 terminal carbonyls. This is about Ni5 CO12 2-. Thank you.